I have a system of equations and we're looking for the solution. And we have y equals negative 4x plus 6 and we have 2x minus y equals 11. So since the first equation is given to us in the form of y equals, we're going to take what y is equal to and substitute it into the other equation for y. Pay attention though when we do that. We need to make sure that we use that negative and that when we substitute in everything, that negative 4x plus 6, everything needs to be negated. So the sign will change on everything. Let's take a look at what that turns out to be. Okay? So we can see here, we're going to substitute in the negative 4x plus 6, and then this is what I was talking about. You have the negative that was in the original equation that we're substituting into. So what does that look like when we actually substitute, or you can also think of it as distributing a negative 1. So that gives us 2x plus 4x minus 6 equal to 11. Once we've dealt with that pesky distributing the negative 1 business, now we can go ahead and combine like terms. That gives us 6x, and then if you add 6 on each side, equal to 17. Dividing by the coefficient here is 6, so dividing by 6 on each side gives me x equal to 17/6. I'm going to substitute that into either of my original equations. Probably best to substitute into the one that's already set up to help you find y equals. When we do that and work through the math, we're going to get y equals negative 16/3. I'm going to take these two values now and write them as an ordered pair. So we have 17/6, comma, negative 16/3. Now, you could try to get that from the graph. It's there. I think it's unlikely that you would have been able to get that with very much precision. So this is a case where we're really grateful to have some algebraic approaches that would help us find exactly the point and know that it's precisely the answer.